Flack math! Give me some math and I'll give you some flack. Flack math!
All right, there is a property of equality for exponential functions. And I will write it down, but again, prop equality for exponential functions. Says this: if A is a positive number other than 1, then a to the x equals, and a to the x equals a to the y is positive, and not 1. And if a to the x equals a to the y, then x equals y. Now, this seems obvious because a is the same number, and if those two things equal each other, then they have to have the same exponent, right? But this is good to know because we can solve equations based on that as well. So let's try an example. Example 1, A says this: solve for x. 2 to the x equals 16. Well, you can rewrite 16 as 2 to the 4th. This is just 2 to the 4th. 2 to the x equals 2 to the 4th, so x equals 4. Since they have the same bases and they're equal to each other, x equals 4. Now this seems like a no-brainer, but we're going to use this easy example to do something else. Okay? So here's 1b. We're going to solve 9 to the c plus 2 equals 27 squared. Okay? Well, let's rewrite this. You can rewrite this with a common base. So what base does 9 and 27 have in common? So 9 and 27 are both powers of what? 3. So this is going to be 3 squared, but it's already to the c plus 2, right? So remember, you can multiply those together. Well, this is 3 to the 3rd all to the 2nd. 27 is 3 to the 3rd. 9 is 3 squared. So we're just replacing 9 with 3 squared and 27 with 3 cubed. And now we're going to apply those exponents by just multiplying. A power raised to a power, you multiply, right? So this is 3 to the 2c plus 4 and 3 to the 6. All right, now we can do this. Boom, boom. Set those equal to each other. 2c equals 2. C equals 1. Let's just check it, make sure it's right. 9 to the 3rd power is like 729. 27 squared is 729. So far, so good? Okay, so basically you have to get to this point. You have to get to the point where you have the same bases. One exponential expression equals the other exponential expression. Okay, well, let's try using, see if you can do this without a hint. 2 to the t equals 1/16. You could probably just figure this out, but you could do it the way we've been doing it. How do you write 1/16 with a base of 2?
2 to the negative 4?
Right, because this is 2 to the negative 4, which is 1 over 2 to the 4th. 2 to the 4th is 16. So t equals? Negative 4. Pretty doable. Okay, now there's another way to solve exponential expressions by using logarithms. Okay, so let's try that. So this is example 2a. I want to solve 200 equals 1.05 to the x. Okay? So what I'm going to do is just apply logarithms to both sides. Whatever you do to one side, you can do to the other. So I'm going to say the log of 200 equals the log of 1.05 to the x. Okay, so now if I remember the property of logarithms, when you have this exponent, what do you do with that exponent? Do you remember the power rule for logarithms? Do you remember what to do with that? You bring it out in front. So this is log of 200 equals x times log of 1.05. We talked about that on at least 2 days, but yeah, that's one of those power. And then when you like log of something times something, then you can add the 2 logarithms, and then something divided by something, you subtract the 2 logarithms. So now to solve for x, we want to get x by itself. Well, x is being multiplied by this, so we're just going to divide by log of 1.05. Divide by log of 1.05. So then you can put that in your calculator. You have a log button on your calculator, log of 200 divided by log of 1.05, and you get approximately 108.59. Okay? Is that okay? Doable? All right. So let's do another one like that. This is 2b. We're going to solve for y. All right, I think I'm going to write this right. 7 to the 2y plus 1 equals 4 to the negative y. Okay, so obviously 7 and 4, you can't really do anything with that. They don't have common bases that you can pull out. So let's apply logarithms to both sides. So this is, for some reason they switched sides here. I don't know why they did that, but we're not going to do that because we're stubborn. So log of 7 to the 2y plus 1 equals log of 4 to the negative y. All right, so far so good. So this can go out in front. This can go out in front, so let's do that. 2y plus 1 all times the log of 7 equals negative y times log of 4. Right? So now we've got this thing happening. So we have to get our y's by itself. So we have to simplify a little bit. So we're going to distribute this. We have to distribute that to both of them. No problem. 2y log of 7 plus 1 times log of 7 is just log of 7. Okay, and then this one I'm just going to leave alone for now. So now I want to get my y's by itself, get my y's on one side. And then we're going to factor out a y. Okay, so I'm going to pull this over here. And then I'm going to put this over here because I want my y terms on one side. So I want all my y's on one side. So I'm going to rewrite up here. So this is now up here. So now I'm going to go 2y log of 7 plus y log of 4 equals negative log of 7. Okay, now let's factor out a y. You factor a y out, you're left with 2 log of 7 plus log of 4 equals negative log of 7. Okay? So now we divide by this coefficient, right? We don't want to get that x, that y by itself, so we're going to divide by this big chubby coefficient. And so this is what y equals, all that. And you can just math that out for a negative 0.37. Okay? So once you get all your logarithms, you can just isolate the variable. I mean, I guess technically you could calculate these logarithms before you isolate the variable, but you want to do all your calculator stuff at the very end. That way you don't have to round and then round something that's already been rounded. You only want to round once, your final answer. So try to use parentheses on your calculator to do this, negative log of 7 divided by parenthesis, to all that. And just so you only have to round once. That's your goal. Okay, so let's move on to natural logs, or solving exponential expressions with the constant e. E is the constant for exponential growth that we talked about. Watch that awesome video with the cool accent. Okay, so let's do an example with e in it. We're going to solve for 5 equals 6e to the x. So here's example 3. So 5 equals 6e to the x. We're going to solve for x. Hi. Thank you. Okay. So please tell me you're recording. You are. You are. Yes, I'm recording. So I'm recording. So you can watch the beginning part a little bit later. All right, so we're going to solve for this. 6e to the x equals 5. So let's just apply the natural log to both sides. Okay, for some reason they put them over here. Let's do that. So it just makes me feel better too. So let's just apply the natural log to both sides. Okay, and the reason why we want to do natural log is because we want to somehow utilize that e, because natural log is just log base e, right? So natural log of e would be 1. Okay, so let's do that. Let's take this x, put it out front again. But you can't do that yet. You can't do that yet because this is 6 times this. So you can't, this x only applies to the e. So we have to, this is multiplication. So we have to separate this into 2. Natural log of 6 plus natural log of e to the x. So remember the product rule for logarithms is when you have a product, you're taking the log of a product, you can separate it into 2 logarithms by adding them together, okay? So now we can take this x and put it out there. But we also, let's just pull this over here since we're trying to get that x by itself. So let's get that over there. So now we have x times the natural log of e equals natural log of 5 minus natural log of 6. Okay? So what's the natural log of e? 1. Right? Because remember, the natural log is just log base e. So what exponent do you apply to this base to get e? Just 1. So this is just 1. So that's x equals whatever this is minus that. Well, you know how to do that on your calculator. So it's just natural log of 5 minus natural log of 6, which is approximately negative 0.18. or 1/8. Okay? So there's two ways to do it. If you can find a similar base, which is what we talked about before you got in here, if you can find a similar base, then do it. That's probably the easier way to do it. If not, then apply logarithms to both sides. So you have to get like one term equals one term first before you do that, but that'll do it. Okay, next. Same chapter. Now we're going to talk about inequalities. Remember, inequalities are pretty much the same thing as equations, but sometimes there's a weird rule, like you have to flip the sign or something. So let's look at example 4. Okay. Suppose you receive a gift of 1 cent. Ooh. On the first day, 2 cents on the second day, and so on, receiving double the amount on each day. What is the first day on which you will receive more than $1 million? Okay, so this is that little, remember doing that scenario where you get a summer job and he offers to pay you 1 penny and then double your pay every day. You'll end up with more than $10 million by the end of the month. So it's a good, if someone ever offers that to you, then take it. What?
That's some good life
Yeah.
advice.
Yeah, it would break my heart. I mean, like even if someone said, I'll give you $1 million today, or I'll double your pay every day, but you're starting with a penny. Take it. All right. So here's the deal. We want to know when we're going to get more than $1 million. So on day 1, you receive 2 to the 0 cents. Okay, so day 1 is 2 to the 0 cents because you're doubling it, right? And that's just 1 penny. Anything to the 0 power is 1. On day 2, so you get 2 to the 1. On day 3, you get 2 to the 2nd. On day 4, you get 2 to the 3rd. So you're basically adding an exponent every time, right? Okay, so your equation is going to be 2 to the n plus 1 is greater than 10 to the 6, which is $1 million, right? Okay, so we want to know what n on what day is day 1. So we have to add ones because day 1, see how day 1, it doesn't, what day it is. So we have to add 1 each time because the exponent is going to be 1 less than what day it is. That's why they do the n plus 1. Okay, well, 10 and 2 do not share a common base. 10 is not a power of 2. So let's logarithm both sides. So we're going to go log of 2 to the n plus 1 is greater than log of 10 to the 6. So far, so good. What do you do with these exponents? What do you do with those exponents? And this is why applying logarithms works, because you can get them out of exponents and just normal factors. Okay, so this is n plus 1 all times log of 2. So we're going to distribute that. And then this is just 6 times log of 10. Okay, what's the log of 10? Do you remember what the base is if you don't see a base? This is also called common log. That's natural log. What's the base if you don't see a base?
10.
10. So what's log of 10? 1. So this is just 1. Okay, that's nice. So let's distribute this. N log of 2 plus 1 times log of 2, which is just log of 2. Okay, get rid of log of 2. So you get n log of 2 is greater than 6 minus log of 2. Now divide by log of 2. And n is greater than that. So basically, you can calculate the rest of that. I think more than $1 million. What? 10 to the, why did they say 10 to the 8th? Is this a typo? Oh, you know what they did? Is it cents? So they had to have 8 there, because $1 million is 100 million cents, right? Multiply by 100. So that's why they had 8. Sorry. Clever girl. Okay. So then you got basically 8 over log of 2 minus. Why minus? What do we do there? Oh, yeah. Here's where my eyes are awesome. So this should be minus. Sorry. Because, yeah, the philosophy was right, but it's, yeah, -1, not +1. So that's plus, it's minus, that's plus, plus. So you got that scenario. So you could simplify that and say 8 over log of 2 plus 1, because those log of 2s would cancel on the next one. But you could just do the math there, and you get 27.6. So n has to be greater than 27.6 days. Okay, so on day 28, you're going to get more than $1 million. But then it doubles from there, which is nice, right? Day 29, get $2 million-ish. 34 million, and if there's 31 days, you get 8 million. But then that adds to everything that you've gotten before. So you get over like 15 million, I think. All right. So that's an inequality. So you'll probably find some problems in there in your homework. The equation, getting the right equation is a little bit challenging, but if you need a little nudge, check out your solutions manual. Just to get that initial equation, see if you can figure out the rest. But that is 93. Let's move on to 94. All right, rational inequalities. Rational, remember, just means some fractions, algebraic fractions. Inequalities is less than or greater than. So let's just start. A rational inequality is an inequality that contains at least one rational expression that can be solved algebraically or graphically. When a rational inequality is solved by using the least common denominator could be positive or negative. Okay, so let's try this. We're going to try to solve this rational inequality. 6 over x plus 2, it just became rational, is less than 8. Okay? So least common denominator is a nice word for f-bomb. So what's the f-bomb in this problem?
X plus 2.
X plus 2. So we're just going to multiply both sides by x plus 2 and get rid of that fraction. Over here, it's nice because it just cancels and you're just left with 6. This, you got to do a little distribution, but okay, get divide by 8, x is greater than negative 5/4, or yeah, they should have like 1.25 on there. But that's it. Does that make sense? So let's try another one. We're going to solve by finding the values of test points. Okay, well, let's try that. So this is where it gets a little bit more complicated. Not too bad, though. We're going to solve x plus 4 over x squared plus x minus 6 is less than or equal to 0. Okay, so when I see something like that, what's your first knee-jerk reaction, which is probably the right reaction? When you see a trinomial, what do you want to do with all of your heart?
Cross out the 2 x's.
The what?
Get rid of the 2 x's.
Oh, you're rusty, aren't you?
Yeah.
It's a Monday. It's basically a Monday for you guys. So you can't cross that out because you can only cross out similar factors. That's not a factor. But I see a trinomial, and I have this sudden urge to factor it out, right? So how's this factor? X plus 3, x minus 2, right? Unfortunately, nothing cancels, but that's okay because we're trying to solve this, and we're also trying to figure out what's going to break it, okay? So the numerator is 0. So numerator is 0 when x equals -4, okay? So let's just say x equals -4, and we're going to just leave that for a second here. The denominator is 0 when x equals 2 or -3. So the denominator is where x equals -3 or 2. And those are the things that break it, right? So when you graph something like this, whenever you have things that break something, you're going to have asymptotes. Okay, where it's going to approach something but never quite touch that, because if it does, it's going to be undefined. All right. So now what we have to do is we have to check our boundaries. So right here we've got if I were looking on a graph here at x equals -3, there's naughtiness, and x equals 2, there's naughtiness. Okay, and then x equals -4 is where it crosses the y-axis, okay? So x equals -4 is where it crosses, yeah, the y-axis. Am I saying that right? Is where y equals 0. Yeah, so this is where it crosses the x-axis, okay? So this is going to cross at that point. All right, so this is what we have so far. So now what we have to do is we have to check these different intervals. There's this interval over here. On this side, there's this interval in between, and there's this interval here. Okay, and there's also an interval in between that and that first asymptote. Okay, so let's first check over here and see if anything less than -4, what that's going to do. Okay, so let's try -5. So we get -5 plus 4 is -1. And then over here, we get 25 plus -5 is 20 minus 6 is 14. So you get -1/14. Is -1/14 less than or equal to 0? Is it? Well, negative anything is less than or equal to 0. So guess what? This interval is true. Anything less than -4 is true. Okay? So let's plug in the next interval. The next interval is this little guy right here in between -4 and -3. Okay, this is kind of annoying, but you got to do it. And you can use your calculator. But the only thing that's easily in between -4 and -3 is -3.5. So you plug that in and you get 0.5 on top, right? -3.5 plus 4 is 0.5. Well, this you're going to get, let's see, you just want to see if you're going to get a negative number, right? Because a positive divided by a positive is not going to be less than or equal to 0. Okay? So if you get a negative, so 0.5 is 0.25 plus 0.5 is 0.75. Oh, that's a negative point. So 0.25 minus 0.5 is 0.2. Minus 6 is a negative number. So guess what? This is true as well. So in between -4 and -3 is also true. Okay? All right? Oh, I plugged in the wrong value. I plugged in 0.5 instead of 3.5. This is not true. You end up with a positive divided by a positive, so this is false. Use your calculator. -3.5 squared is something big, plus a -5. So you're going to be big enough to where you subtract 6, you're still positive. So it's going to be a positive divided by a positive, which is not less than or equal to 0. Okay, so that's false. Now let's try this interval right here. What's the most obvious choice in between -3 and +2? 0. So 4 over -6. Is that true? Is that going to be less than or equal to 0? Positive divided by negative is negative. It's less than or equal to 0. So you want to end up with a negative over here to see if it's true. So yes, in between -3 and 2 is true. Okay, and actually we can't do less than or equal to because we know that -3 is not true and 2 is not true. It makes it undefined. So these guys are strictly not okay there. Okay? All right, the next interval is just greater than 2. So let's pick like 5. 9 over 25 plus 5 is 30 minus 6 is 24. 9/24. Is that less than or equal to 0? No. Positive 9/24 is not less than or equal to 0. So this is false. So that was a lot of work to give the answer, which is just x is less than or equal to -4, or -3 is less than x is less than 2. Those are the only intervals out of the 4 intervals that are true. Okay, and if you had to do this at Red Rocks, you would write it like this. Do you remember how to write it, Delaney? How do you write these this interval?
I didn't take that.
Oh, you didn't? But didn't you do interval answers for something? Was that for the SAT?
Probably.
So this goes from -infinity, parenthesis, all the way up to -4, bracket. So this is like less than or equal to. And then united with this guy, which is -3 to 2. And they're both parentheses there because it's not less than or equal to. So that's how you would have to write your answer in if you're doing math at Red Rocks online. Okay, so solving rational inequalities using sine tables. So sine tables are just positive and negative tables, not like sine and cosine tables. Okay, so let's just try one of these. And then the next one is just using a graphing calculator, so we'll skip that. But let's just do this last one and then we'll call it a day. It's example 3. And we're going to solve x minus 6 over x plus 2 is greater than 1. So we need to solve for x's. Okay? Oh, no, it's greater than 0. Okay. So basically you want to solve for 0. It's kind of like everything else where you want 0 on one side. So the right side's already 0. Find the boundary points. So again, we have to find these boundary points. So the numerator, for it to be greater than 0, well, let's just have it equal to 0. X equals 6 to make the numerator 0. All right, the denominator, x equals -2. So here's our boundary points. Okay, so we've got 3 intervals. If we wanted to do it this way, we have 3 intervals. We have everything before -2, everything in between -2 and 6, and everything after 6. You see the 3 intervals? But we're not going to do it that way. We're going to do it with the sine table, okay? So we're going to test these. We don't even have to graph them. So they're listed top row with the test value below them. Okay, so here's like a little sine table they did. So they did test value for x. So they're just picking values here. This is not a set thing. You can do whatever you want. And they have a numerator. X equals -6. I put, or x minus 6. Okay, and then here's our intervals. X is less than -2. X is in between -2 and 6. And then the other interval is x is greater than 6. Those are the 3 intervals, just like we did on the last one. Okay, we're going to do test value and then look at the numerator and denominator and just figure out if it's positive or negative. Okay, so here's the numerator, x minus 6. Here's the denominator, which is x plus 2. And then overall value of rational expression, exp. Okay, so we're gonna try some test values. We're gonna plug in -3 because -3 is less than -2. All right. Does this make the oops, the test value goes up here. Sorry. There's another row here. Sorry, it's messy. But when you plug in -3, does that make that positive or negative? Negative. When you plug in -3 there, does it make positive or negative? Negative. So you have negative over negative, which makes this positive. All right. So since 0 is one side, all you have to do is you don't have to get a value. You just have to get whether it's positive or negative. Okay. So when you plug in, let's plug in 0. What does that make that? Negative. What does that make that? Positive. Well, negative divided by a positive is a negative. Okay. Let's plug in 10. 10 minus 6 is 4, so that's positive. 10 plus 2 is 12, so that's positive. Positive divided by positive is positive. Which ones are true? These guys are true. So we got our answer is x is less than -2 or x is greater than or equal to, nope, not equal to, greater than 6, because equal to would make it 0, and we don't want it to be 0. We want it to be greater than 0. Okay? So that's using the sine table. That works out pretty well too. The next example has like 3 factors on the bottom, so you're going to have 1, 2, 3, 4, 5 intervals that you have to check. But that's the process. That's the deal. Good? All right.
Black math, give me some math and I'll give you some flack. Black math.